Today, artificial intelligence helps doctors diagnose patients, pilots fly commercial aircraft, and city planners predict traffic. But no matter what these AIs are doing, the computer scientists who designed them likely don't know how exactly they're doing it. This is because artificial intelligence is often self-taught, working off of a set of instructions to create a unique array of rules and strategies. So how does a machine learn? There are many different ways to build self-teaching programs, but they all rely on three basic types of machine learning. Number one, unsupervised learning, supervised learning, and then lastly, reinforcement learning. So to see these in action, let's imagine researchers are trying to pull information from a set of medical data containing thousands of patient profiles. First up, unsupervised learning. This approach would be ideal for analyzing all the profiles to find general similarities and useful patterns. Maybe certain patients have similar disease presentations, or perhaps a treatment process that is specific to those set of side effects. This broad pattern seeking approach can be used to identify similarities between patient profiles and find emerging patterns, all without human guidance. But let's imagine though the doctors are looking for something more specific. These physicians want to create an algorithm for diagnosing a particular condition. They begin by collecting two sets of data, medical images and test results from both healthy patients and those who are diagnosed with that condition. Then they input this data into a program designed specifically to identify features shared by these sick patients but not by the healthy patients. Based on how frequently it sees certain features, the program will assign values to those features' diagnostic significance, generating an algorithm to diagnose future patients. However, unlike this first unsupervised learning, doctors and computer scientists have an active role in what happens next. Doctors will make the final diagnosis, check the accuracy of the algorithm's prediction. Then computer scientists can use these updated data sets to adjust the program's parameters and improve its accuracy. So this hands-on approach is called supervised learning. Now, let's say these doctors want to design another algorithm to recommend treatment plans. Since these plans will be implemented in stages and they may change depending on each individual's response to treatments, the doctors decide to use reinforcement learning. This program uses an iterative approach, or which is colloquially called the loop approach, to gather feedback about which medications, dosages and treatments are most effective. Then it compares the data against each other's profile to create their unique optimal treatment plan. So now there are numerous ways, as you can see, to create these machine learning systems, and perhaps the most promising models are those that mimic the relationship between neurons in the brain and the machines. These artificial neural networks can use millions of connections to tackle difficult tasks like image recognition, speech recognition, and even language translation. However, the most self-directed models become the more harder it is for computer scientists to determine how these self-taught algorithms arrive at their solution. Researchers are looking at ways to make machine learning more transparent, but as AI becomes more and more involved in our everyday lives, these enigmatic decisions have increasingly larger impacts on our work, health, and safety. So as machines continue learning to investigate, negotiate, and communicate, we must also consider how to teach them to teach each other to operate ethically, because that's one thing that they can never know unless we teach them.